Hey guys, welcome back. It's been a while since my last video. I've been super busy with coursework in general, so I haven't had much time to document or record my work. I was trying not to fail my Haskell course, but I did pretty good on the final, so I am passing now. I've actually done a lot of work. I basically did complete this project. I just didn't have time to record because I need to script a little bit, and I felt it would have been a better use of my time to write code, and then I'll explain it by basically live coding what I've done. There was some functionality in Haskell that I used in this Python code base with like zip and list comprehension. So I think that the Haskell course did teach me a lot, and I can use some of that in here. So let's get started. The first thing I wanted to say is this. I said I'll confirm if this is right or not, and it turns out that I was right. If it's reversed, then it will be in the same order as the original donor list, and if it was reversed, then it would be if it was in order, it would be reversed of the donor list, and if it was different, then it would be different all around. And the classifications, which is in order, reverse, indifferent, does not care for genes in between the gene families. So if there was like a 20 here, like gene family number 20, that would not mess up anything. If it was 11312111139814 for the recipient, it would still be reversed. All right. So I actually have two versions of the project. One of them had bugs in it, and then I had to refactor my code. But it taught me a lot when I did fail, because I realized that my second way of doing it is a bit more pretty or efficient, even though it's a whole lot of for loops. I understood the code a bit more than the first version, which is this one, which is a plus in my book, because if I can read it better and understand it more, I'm able to make more changes more clearly if I need to in the future. So I'll show you the bug that was in this version. The version we decided on before was strictly only looking at the gene families at the recipient, but it didn't take account of duplicates. So if there was So in this example here, there is 2 gene families with the number 6980. See, it's right here. Because there was 2, my first version parsed when we first, if there was any element in the donor list that we passed in inside the content where the gene transfers take place, then we pluck the first one out and then we append. We keep appending until all these values are in the final. So as you can see, it's 21786, 8732, 28, 10, 947, and then 6980. Yep. And then another issue I had with this was transfers all supposed to have 3, at the minimum of 3. So some of these outputs only have 2. I think these are just because it's edge cases, it goes into a different line or it's too far away. Yeah. So this is my first version of it. It's not the prettiest thing because it's full of bugs. Well, display visual issues and not parsing the correct stuff. So I created this test3 file, Python file, so that I could better explain what we are doing. So this video will just be outlining kind of what we need, because I've written this already. The content is grabbed from this dictionary. It starts from here and it goes all the way to the end. And we've done that with the index where the main script runs. The contents is just the local storage struct where it contains the entire transfer. And then the next thing, actually I can say something about what I've noticed. Okay. So the second version, the working version, utilizes indexing for the genes transferred. I didn't realize this at first, but the gene name for the recipient file is actually the index. I'm not sure if it's intended to be the index, but it is. It's the index for when this gene appears in this file. So then, instead of looking strictly at the gene family where there is possibility for duplicates, I will be looking for both or all 3 config, gene name, gene family, if those 3 are all present within one of these elements, and I will transform this file into a list, so then we can compare each element and see if those appear within the index at that element. I'm happy that I found that pattern, because this would have been so much more difficult and I needed to handle so many more errors, edge cases, but luckily we had that. So given that we have the context, we will need to parse the content into blocks, because each of these will be considered a block, and each of the lines in it will be considered a contig line. To blocks, and parse the blocks into contig lines. And then with those lines, we need to parse the lines and strip to get the required parameters for rest of our functions. And then we need to capture the index at gene and compare with the G recipient file / donor file. And it was / donor file because I will explain what additionally I've done to help researchers or people looking at genes and the file understand the starting 2 genes and then the ending 2 genes of each block. And then with that, we can compare end and start for the block of gene families captured. So the reason why you see there's 3 lists is because the middle list is where the actual genes are transferred, and then the first list is the first 2 genes that are sequential to the middle gene, and then the next 2 genes are considered the end, so the 2 genes after this block that we're looking for. And then with that, we need to compare the classification of the transfer, and then finally we need to compare start and ends of both donor and recipient to understand how they correlate and if the genes are transferred only because of certain end and starting genes. And we'll just do this in Excel because in our Excel comparisons, the classification is right here, and the comparisons for the start and ends will be different if they're not the same at all, partial if they are half the same, and if they are conserved, then it's directly the same as what is expected. So the start is the same as the start for the donor and receiver, and then the end is the same for the donor and receiver as well. And then the flipped conserved is just conserved, but for example, start is the same as the end for the donor and recipient, and then the end for the donor is the same as the start for the receiver. Okay, that's kind of all for now. And I will be using this test Python file to write code that we need in order to make this happen. But at the end, I think I will just I'll just pull this repository and run it for you guys, because that's basically what I did. Oh, and you can see here, the zip results is part of Haskell. Python kind of took it from Haskell, so I'm just using zip and making sure it's in the list format, so then we could transfer the combined into the recipient.html, which is here. Okay. I think that's everything I wanted to say for this video. Yeah, I feel bad that I wasn't able to go the entire process with you guys, but I feel like if I explain it a second time and write it all out for you guys again, it will be kind of the same thing, and then it will also help me parse things better and code better. This will not be the most efficient thing in the world. I'm just going to be mixing a bunch of for loops together because kind of the structure we have, or that I implemented, is like this. There will be, okay, so let's say for this transfer here, this transfer, there is there is 23 blocks, and in each of those blocks there's a contact line. So each list is representing one block, and inside the list there is multiple lines. So the reason why we have a bunch of for loops is because I will need to access the index of main list or main array, and then we need to access the element list inside, and then we will also need to dive one level deeper into the actual elements in the list because we can't just access this line directly. We need to go 2 steps in. We need to first access the index, and then we need to find the index within that index, which is a bit complex, and it will take a lot. Well, this is the way that I devised it because it will work with the data sets we have, and time wasn't really too much of an issue. But I made sure to keep the worst case as much out of it as I could. Okay. Thank you guys for watching, and I'll see you.